Hey everyone, my name is Ung Jong, a junior majoring in mechatronics engineering. Today I'll be presenting on the topic of PID control using MATLAB GUI. PID control is a method that utilises the error between the target value and the measured out value for control purpose. It involves using P, I, and D controllers in parallel, and we will examine the detailed characteristic of each controller later in the presentation. First, let's discuss the P controller. The P controller, also known as the proportional controller, adjusts the control variable in proportion to the error value. Compared to other controllers, it is relatively simple and intuitive to design. Increasing the P gain reduces the rise time, which is an advantage, but also increase the overshoot and can cause oscillation near the target value. Next is the I controller. The I controller reflects the accumulated error values from the past in its output. Increasing the I gain improves the system accuracy by eliminating the error, but as the gain increases, the settling time becomes longer. Excessive gain can also destabilize the system. Additionally, it has the disadvantage for contributing to instability when external disturbances are present. Finally, let's discuss the D controller. The D controller improves the system transient response and output a value proportional to the rate of changing of the error. Its advantages include reducing overshoot and the settling time. However, if the gain is too high, the system can diverge. Additionally, since the D controller applies control based on the rate of change of the error, it cannot be used on its own. Next, let me briefly introduce MATLAB. MATLAB is a software primarily used for mathematical computations, data analysis, simulation, and algorithm development. It is widely utilized across various fields such as science, engineering, and economics. Simulink, an extension tool of MATLAB, allows dynamic system modeling and simulation using block diagrams. MATLAB App Designer is integrated with Simulink and is used for GUI development. Let me briefly explain the components of MATLAB App Designer. On the left side, there is a library of GUI components which can be intuitively dragged to the center to design the UI. On the right side, you can configure the UI settings. At the top right, there are buttons to switch between the design and code views. This screen shows how GUI is struck using MATLAB code. Here you can add code to implement functionally for GUI. These simple GUI I created for PID control of this simulator. It allows you to choose whether to control the motor speed or position. It includes a button to modify the model, a button to start the simulation, and a section to apply PID gain values. When you click the Edit Model button, the Simulink model of the model displayed on the screen will open. You can adjust the parameters in Simulink to simulate the system according to your requirements. In the speed mode simulation, you can observe the graph showing how the system reaches the target value depending on the PID gain values. Similar to speed mode, in position mode, clicking the edit model button, you will open Simulink model of the model. You can adjust the parameters in Simulink to simulate the system according to your requirements. The following shows how the system reaches the target value in position mode depending on the PI gain values. Adjusting PI gain can be a challenging process, but by using a GUI like this, you can fine-tune the PI gain values of the system more effectively. This concludes my presentation. Thanks for listening.